Welcome again, Wildcats. All right, so today we're looking at Thursday, October 27th, dividing polynomials with synthetic division. That's going to be it's going to be on page 27. So if you would pause the video and update your table of contents. All right, so let's look at our notes. All right, dividing polynomials with synthetic division. Now, usually I write my own notes, but in looking at, I have a great book. It's a Holt book, and I was looking at notes, and the notes are really good. So a little shout out to Holt, page 423 from their Advanced Algebra 2 book. All right, so we're going to divide 2x squared plus 7x plus 9 by x plus 2. And we're going to do it using synthetic division. All right, step 1. Write the coefficients of the dividend 2, 7, and 9 in the upper left corner. So that's 2, 7, and 9. Write the value of a in the divisor x minus a so that a equals negative 2. And the reason why this is negative 2 and not a positive 2 because a negative times a negative is a positive, so that means the a value is negative 2. Okay, so your a value here is actually negative 2. And I know you might have some, if you have trouble like grasping really that is, just know that when you do synthetic division, you change the sign. So if this is plus 2, you divide by negative 2. Okay, and we'll talk more about that in class. All right, so now copy the coefficient in the division below the horizontal bar. So we're going to, they say copy, I'm going to say bring down the 2. Okay, so that's basically what this sentence is saying. Take the 2 and bring it down. Okay? All right. So step 2. Okay? Now it says multiply the first coefficient by the divisor and write the product under the next coefficient. Okay, so multiply the first coefficient by the divisor and write the product under the next coefficient. So basically what that's saying is you multiply negative 2 times 2, which is negative 4. And then add the numbers in the new column. So they say add, but we're subtracting. So 7 minus 4 is 3. So basically what synthetic division is doing is dividing without the x's. Okay? All right. Now the next thing is to repeat step 2 until additions have been completed in all columns. Draw a box around the last sum. So we multiply negative 2 times 3, which is negative 6. And then we add. So 9 minus 6 is 3. And it says to put a box around that. All right. So the quotient is represented by the number below the horizontal bar. The box number is the remainder. So this is the remainder. The box number is the remainder. The others are the coefficients of the polynomial quotient in order of decreasing degree. So this is 2x plus 3 plus, remember the remainder, we take this number divided by the x plus 2. Okay. All right, so update your notes. All right, so let's look at our examples. And our examples are on page 27. All right, I want you to pause a moment and I want you to look at the examples and ask yourself, where have you seen these problems before? All right, so I'm assuming you paused the video and you thought and you were thinking, and you're like, where have I seen this before? I'm hoping you said that, Mr. Luke, we did these exact same examples yesterday with long division, and that we're doing this on purpose. I want you to see that you can divide polynomials with long division and synthetic division. And I think after you do this assignment, you'll find that you like synthetic division a lot better than long division. All right, so when we divide, remember this is a positive 2, so we actually do minus 2. All right, so now you take the coefficient. So this is a 1, so 1, 5, and 6. Okay, so step 1 is we're going to bring down the 1. Step 2, we're going to multiply. So negative 2 times 1 is negative 2. And then we add. So 5 minus 2 is, and say I add, but really it's add or subtract. So 5 minus 2 is 3. Now we're going to repeat step 2 until we've completed all the additions. So then negative 2 times 3 is a negative 6. So 6 minus 6 is 0. Now when you divide, the exponents decrease. So here, this was 1x squared plus 5x plus 6, but they decrease. So x squared becomes an x, and the x is gone. So it's actually x to the 0 power. So this is a 1. This is x to the 0 power. But we know x to the 0 power is 1. Or if you didn't know, you know now. So that equals 1x plus 3 plus 0 divided by x plus 2. But you know 0 divided by this is 0, so it's just 1x plus 3. Now, you can pause the video and try examples 2 and 3. Just know I'm going to go over example 2 in class tomorrow. All right, so let's look at example 3. I'm going to say we shouldn't look at example 3 because of the 3x plus 1. I think we should do that in class, okay? So let's look at example 4. All right, so example 4. Now it says x minus 4, but we know that when we divide it, it's a positive 4. And we can talk about more, too, why we keep changing the sign with use synthetic division. I'd be curious of what you think and why we changed the negative 4 to a positive 4, or we changed the 2 to a negative 2. So that's my question to you. I want you to come to class prepared to answer why, when we use synthetic division, that negative 4 becomes a positive 4, and positive 2 becomes a negative 2 when we use synthetic division. All right, so we know from step 1 that we're going to coefficient, so this is a 1, negative 3, but don't forget, remember from yesterday that we need the x squared. So that's 0, negative 7, negative 14. All right, so in step 2, well, actually, no, step 1, we're still going to bring down the 1. And now in step 2, we multiply. So 4 times 1 is 4. We add, or subtract how you want, but negative 3 plus 4 is 1. And then we just keep repeating till we've done all the additions. So 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. And then negative 7 plus 16 is 9. And then 9 times 4 is 36. Negative 14 plus 36 is 22. So remember, this was 1x to the 4th minus 3x cubed plus 0x squared minus 7x minus 14. So this was the 4th, now it's x cubed plus 1x squared, because that was a cube, now it's a squared, plus 4x plus 9, and then you have a remainder of 22. So that equals 1x cubed plus 1x squared plus 9 plus 22 divided by x minus 4. Now, what I would do is go back to your examples and notes from, or actually just your examples from yesterday, and compare example 1 and 4 and see what you should see. Okay, there's something you see when you compare example 1 and 4 from yesterday to today. All right, so I'm going to go over example 2, 3, and 5 in class. So as always, I want you to have a terrific Wildcat day.